So hello everyone. Hello everyone. So today we are going to discuss on the 741 OPAMP IC, and we have here the experts Mr. Suresh Devedi at EFY. He is engineer at EFY. So our first question is, what is 741 OPAMP and what is the primary function of electronic circuits? You need to unmute.
The 741 op-amp is a general purpose amplifier that has been widely used in electronic circuit since its introduction in the late 1960. It is known for its versatility, reliability, and ease of use. Here are the main functions of the 741 op-amp. First one is the amplifier. This op-amp is commonly used as a voltage amplification. In this, op-amp can amplify the difference between the two input voltage. It has high gain, typically around 2 lakhs, and it also has a current amplification. It can be used in a configuration to amplify the current in the transimpedance application. Another application of this 741 is a signal conditioning. It is used as a filtering. In this, it is configured as a active filters such as low pass filter, high pass filter, and band pass filter. Another is it is also used in a signal mixing. It combines multiple input signals into a single output. And third, it is useful in the mathematical operation such as adder and subtract. It can perform addition and subtraction of input signals. Another is integration and differentiation. So it can be used to perform the integration and differentiation of the input signal, which is very useful in the analog computing. Another application of the 741 is a oscillation. It can be used as a generating waveform outputs such as sine wave, square wave, and triangular wave. Oscillator circuit can be built through this 741 op-amp. Another application of this is a used as a comparator, which is very common useful. It can be used as a compare for comparing two voltage of the outputs, a digital signal indicating which is a higher. So it is a very common use of this 741 as a comparator. Another application of this 741 is a buffering, voltage follower buffer. It provides high input impedance and low output impedance, useful for which is useful for the different applications, right? So these are, and it has also some characteristics such as it has a input impedance, high input impedance, which minimize the loading effect on the proceeding stage. Another characteristic is a output impedance. Because of the low output impedance, it allows it to drive low impedance load effectively. Another is bandwidth. Next, it moderate high bandwidth suitable for many audio and control applications. Slew rate, moderate slew rate, which limits its performance in high speed oscillation. Offset voltage setting, small offset voltage setting, which may require adjustment of precision. So these are the characteristics of this 741. That's all.
Okay, so can you explain the integration of 741 and the function of each pins?
Yeah, sure. So this 7-4 operational amplifier is typically housed in a 8-pin dual in package. So its pin configuration can be it has normally 8 pin IC. So pin 1 is used for the offset null. What is offset null? This pin is used to adjust the input offset voltage of the op amp by connecting a potentiometer between pin 1 and pin 5. Other offset null pin. You can fine tune the op amp to minimize the output offset voltage when there is no differential inputs. Pin 2. Pin 2 is the inverting input, V minus. This inverting input terminal and this voltage applied to the pin is inverted. That is a 180-degree output of the phase at the output. When signal is applied to this pin, it causes an opposite change in the output voltage. So it is known as the inverting input. Pin 3 is a non-inverting input. Non-inverting input terminal. In this, voltage applied to this pin appears in the phase at the output. Signal applied to this pin will cause a corresponding change in the output voltage without inversion. Right? So this is the input, non-inverting input P plus. And pin 4 is a negative power supply. This pin connects to the negative power supply voltage for the typical dual power supply configuration. This might be minus 15 volt. For single supply operation, this pin is often connecting to the ground. Normally, when you are using the op-amp, so mostly dual power supply means plus 12, 0 and common minus 15 use. So similarly, when you are using a dual power supply, the negative terminal. When you are using a single power supply, then use this pin to ground. Right? And pin 5 is offset null set, like that pin 1. This pin is used for offset voltage adjustment, connecting a potential between pin 1 and 5 for the adjustment of the input offset voltage. While pin 6 is the output. This is the output pin of the op-amp. This amplified signal from the input pins is available here at this pin number 6. This pin drives the load connecting to the op-amp. And pin 7 is a positive power supply. And this pin connects to the positive power supply voltage for typical dual supply configuration. The might be plus 15 volt. For single supply operation, this pin might be connected to the positive voltage of the source such as plus 9 or plus 12, whatever the supply you are using. The positive rail is used at the pin number 7. Pin 8 is not connected anywhere else. This pin is not internally connected to the op-amp circuitry. It is typically left unconnected or used for the mechanical supports. So these are the pin configuration of this op-amp 741 IC.
So, what are the characteristic of 741 op-amp, including the input bias current and input offset voltage? So, can you give more detail on these things?
Okay. Can you repeat the question, please?
So, what are the typical characteristic of 741 op-amp, including the input bias current and input offset voltage?
Okay. The 741 operational amplifier has several key input characteristics that defines its performance in the various applications. These characteristics include input bias current, input offset voltage, and other related parameters. Here are the typical uh, characteristics of the op-amp 741 op-amp. First is the input bias current, right? So in this, actually, what is the input bias current? The input bias current is the average of the DC current required by the input terminals to properly operate the transistor inside the op-amp. Actually, this is the basically input bias current. And typical value of this is around 80 Na, nanoampere. It is very small current at the room temperature. And the impact, the input bias current can create a voltage drop across the resistance connected in series with the input potentially different, affecting the accuracy of the high impedance circuits. Another is input offset voltage. What is the input offset voltage? The input offset voltage is the differential DC voltage required between the input terminal of the op-amp to make the output 0 volts. Typical value of this input offset voltage is 2 millivolt, but can range from 1 millivolt to 5 millivolt. What is the impact of this input offset voltage? The input offset voltage can introduce errors in the precision application as it creates a unwanted voltage difference that need to be compensated for the accurate measurement or the operation. And the third is input offset current. What is the input offset current? The input offset current is the difference between the bias current entering the inverting and non-inverting terminal. Its value is around 20 nano ampere. What is the impact of this? This parameter is important in the application where precise current balance between the input terminal is critical. Another is input impedance. So what is the input impedance? The input impedance is the resistance seen by the input signal when connected to the op-amp input terminal. What is the value of normally input impedance in this 741 is 2 mega ohm. Its impedance is very high. So what is the impact when we have the high input impedance? The high input impedance is desirable as it minimizes the loading effect on the preceding stage of the circuit. So this is a very important parameter. And another one is a common mode input voltage range. Common mode input, what is the common mode input voltage range? It is a common mode input voltage range is the range of the voltage that can be applied equally to both input terminals without affecting the normal operation of the ampere. So that is the reason why it is known as common mode input voltage. Its range is typically plus minus 12 volt within plus minus 15 volt power supply. Means plus minus to plus 12 to plus minus 12 to plus minus 15 volt you can use. So what is the impact? Exceeding the common mode input voltage range can result in the improper operation of the uh, operation or distortion. So these are the input characteristics of this is very crucial for designing circuits that leverage the 741 op-amp capabilities while mitigating of potential issues causing by the non-ideal behaviors. For precision application techniques such as offset nulling and the careful resistor selection can be managed these characteristics effectively. That's all.
So, can you explain what are some common application of these ICs in the electronic circuits? So, what are the application?
So 7-4 operational amplifier has a versatile component used in the wide range of the electronic circuit. Here are some common applications of this 741 is where you can use in the electronic circuit. One is that it can be used as a voltage follower, normally known as buffer. So what it function? What is the function of this voltage follower or buffer circuit? It provides high input impedance and low output impedance effectively isolating phases of a circuit. Another application where it is used, the voltage follower buffer circuit is used to prevent a loading effect when connecting high impedance source to a low impedance. That's and the second common application is inverting amplifier. It inverts the phase of the input signal while amplifying it. Right? Where we use this inverting amplifier, application of the inverting amplifier is it used in the signal processing to invert and scale signal amplitude. How it's configured? It is its input signal is applied to the inverting input through a resistor with feedback from the output to the inverting input through another resistor. Another application is non-inverting amplifier. This 741 is used as a non-inverting amplifier. So you can say that what is the function of non-inverting amplifier? The amplifies the input signal without inverting its phase. This is a non-inverting. When what the signal is in input, the same signal will be in the output. There will be no inverting. So this is known as non-inverting amplifier. So where it is used, what is the application of non-inverting amplifier? It is normally used when the phase preservation and amplification are the required. What is the configuration of this non-inverting amplifier? Its input signal is applied to the non-inverting input with the feedback from the output to the inverting input through a voltage divider circuit. Right? So another application of this is the summing amplifier. What what is the function of summing amplifier? It sums multiple input signal into a signal output signal. Application where the summing amplifiers are used. So it is used in audio mixing, signal combination, and other application when where multiple signals need to be combined. And configuration of this summing amplifier is it is a multiple input signal are fed into the inverting input through an individual resistor with a single feedback resistor. Another application is that it is used in a differential amplifier. And what is the function of differential amplifier? The amplifier that the differences between the two input signals. Where differential amplifiers are used, these are used in a instrumentation and sensor signal processing where the differential signals are the commonly used. So what is the configuration of this? Both inverting and non-inverting inputs receive signal with the feedback provided to the both inputs. Another application is integrator. The 741 is used also as a integrator. In this, how it functions, it produces an output that is the time integral of the input signal. Application of the integral is it is used in analog computing, signal processing, and control systems. How? What is the configuration of? Configuration of the integration is its input signal is fed into the inverting input through a resistor with a capacitor in the feedback loop. Similarly, as it is used as an integrator, similarly it is also used as a next application is a differentiator. Functions may it produces an output that is the time derivative of the input signal. Application of the differentiator is it is used in signal processing to detect a rapid change or edge in the signals. What is the configuration? So its input signal is fed into the inverter input through a capacitor with a resistor in the feedback loop, means just opposite to integrator. And another application of this 741 is it is used as active filters. What is the function of filters? Filters signal filters signals to allow certain frequencies to pass while attenuating others. Where it is used in audio processing, communication system, and signal these things. How many types of the active filters? It has four part, four sections. One is the low pass filter, passes only the low frequency, attenuates the high frequency. Another is a high pass filter, which passes the high frequencies, attenuates low frequency. Another is a band pass, passes a specific range of the frequencies and attenuates others, means high or low. Particular range is only passes. And another is a band pass filter. It attenuates a specific range of frequency, passes the other. Another application of the 741 is a comparator. What is the function of comparator? It compares two voltage and output is register signal indicates which is high. Where it is used, what is the application of the comparator? Comparator are used in the zero crossing detector, pulse width modulation PWM circuits, and the digital logic interfaces. What is the configuration of the voltage comparator? One input of is set to a reference voltage and the other receives the input signal. Another application of the oscillator, another application of the 741 is the oscillator. What is the function of the oscillator? It generates periodic waveforms such as the sine wave generate, square wave generate, or triangular wave generate. Means using this 741, you can generate three types of the signals: sine, square, and the triangular. What is the application of the oscillator? It is used in signal penetration, function generation, and timing circuits. What is the configuration of this? Positive feedback network determines the frequency and shape of the oscillation. Another application of the this 741 of M is it is used as a voltage comparator. What is the application of the voltage compression? It is used in analog to digital converter ADCs and voltage level detection and threshold application. What is the function of this voltage comparator? It compares an input voltage against the reference voltage. And another application, it can be used as a peak detector. Means 741 can be used as a peak detector. By these, there are various applications, and these are the few example of the application of the 741.
Okay. So, what is the frequency response of this IC and how does it affect the overall performance of the different application?
The frequency response of this operational amplifier, like 741, is a crucial parameter that determines how the op-amp performs across the different frequencies. Frequency response affects the gain, phase shift, and the overall performance in the various applications. So, few applications are gain width product, GBP. The 741 op-amp has gain bandwidth product of the approximately 1 megahertz. Means that that means the product of the gain and bandwidth is a constant. For example, if op-amp is set for the gain of 10, the bandwidth over which this gain can be maintained is 100 kilohertz. Right? So this is the first one. And second one is this is the loop gain. Loop gain. What is the loop gain? Loop gain in loop gain characteristics at low frequencies, the 741 op-amp typically has an open loop gain of the about 16 at 160 dB. However, this gain decreases as the frequency increases. The open loop gain decreases by 20 dB per decade of the frequency due to internal compensation capacitor, which ensures stability but limit high frequency performance. And another characteristic is the unity gain bandwidth. The frequency at which the open loop gain falls at 1 and means 0 dB is known as the unity gain bandwidth. For example, 741 op amp, this is around 1 megahertz. And another characteristic is the slew rate. The slew rate of the 741 op amp is typically 0.5 volt per microsecond. This limits the maximum rate at which the output can change and therefore affect high frequency performances. And frequency response curve. The frequency response curve of the 7.4 op amp is typically show a high open loop gain at low frequency that decreases logarithmically as frequency increases. Right? So this is usually depicted on a board plot where the gain is in dB versus frequency in hertz is plotted on the logarithm scale. Now, what is the effect of the differential application? This is another characteristic. In this, in different applications, in first what effect is the low frequency application. In the low frequency applications, for example, say there is audio amplifier. Uh, at audio frequencies, say 20 hertz to 20 kilohertz. This is the audio range. In this range, the 741 op amp performs well because the frequency is well within the bandwidth. The high open loop gain ensures good amplification and low distortion. And in case of DC signal amplification, for DC and low frequency signals, 741's high gain and stability makes it suitable for the precise signal. And second one is the medium frequency application. This is the low frequency application. Another effect, what is the effect on the medium frequency application? So it filters the 741 can be used to implement active filters such as low pass filter, high pass filter, band pass, and the band stop filters up to a few hundred kilohertz. The decreasing gain with frequency must be considered when designing these filters to ensure they meet performance criteria. Another is a medium frequency application is oscillators. It generates waveforms in R square waves. The 741 can be used effectively within the band limits. Another differential application is high frequency application such as RF amplification application. 741 is generally unsuitable for the high frequency. This 741 op-amp is not suitable for the RF frequency range. And it is another is a fast pulse circuit for application require fast response time and the high slew rates such as certain digital signal processing tasks the 741 may not perform. Means for the high performance it's RF application and fast pulse criteria, this IC is not suitable for this. So, practical consideration you can say internal compensation makes the 741 op-amp stable but limit its high frequency performance. For higher frequencies, other op-amp with higher gain bandwidth product and simulate are preferred. So we should avoid to use in the higher frequency cases, right? So, in brief, 741 op-amp is well suited for the low medium frequency application due to its high gain at low frequency and moderate gain bandwidth product. Its performance degrade at the high frequencies. And that's all.
So, what are the power supply requirements for this IC, and how does it affect the overall performance of the circuit and the overall performance of the op-amp?
So 741 op-amp typically requires dual power supply, right?
Mm.
Means it needs both positive and negative power supply voltages. The recommended power supply voltage range for the 741 op-amp is typically around plus minus 5 volt to plus minus 18 volt. Right? This means that the positive supply voltage V plus should be between 5 and 18 volts. And negative power supply should be V minus should be between minus 4 minus 18 volts. The power supply voltage directly affects the performance of this op-amp. First, so first performance is one is the signal swings. Power supply voltage determines the maximum and minimum output voltage that the op-amp can provide. With the wider power supply voltage range, the op-amp can accommodate a larger signal swing without clipping the output. So you may say it directly affects the performance. Another performance affecting parameter is a headroom. The difference between the power supply voltage and the output voltage is the called headroom. Having sufficient headroom ensures that the op-amp can operate without saturating or clipping the output signal. Third affecting performance is a common mode range. The
Mhm.
power supply voltage also influence the common mode input range of the op-amp. A range determines the range of input voltage that the op-amp can accurately handle without the distortion. Another effect of the performance is a dynamic range because it is a dynamic range of the op-amp which is the range between the largest and the smallest detectable input signal is affected by the power supply voltage. So higher power supply voltage can provide a wider dynamic range. So another affecting performance is the slew rate. In some cases, the slew rate of the op-amp can be influenced by the power supply voltage. Higher power supply voltage may allow the faster slew rates, which is important in high speed application. Right? So, it's important to choose voltage within the recommended range specified by the op-amp data sheets. Operating the op-amp outside of the range can lead the decreased. Clean and stable power supply is crucial for the optimal. Right? So these are the basic parameters of the performance. Okay.
Okay, so now I want to ask one more last question from my side. So, how does this IC handle the noise, and what are the noise specification of this IC? So, can you put some light on this?
Okay. Why not? So the 7-4 operational amplifier handles noise through its internal design
Okay.
and specification, which includes parameters that quantity uh, quantify the noise performance. The key aspects related to the noise in the 741 op-amp includes its input noise voltage and input noise current, both. So, few parameters which affects the noise are the common mode rejection ratio, CMRR, common mode rejection ratio. This CMRR measures the ability of the op-amp to reject common mode signals, which are the identical signal present on both input terminals. Right? A higher CMRR indicates better rejection of the noise and interference that affects both input equally. Right? Another parameter is a power supply rejection radio. PSRR, power supply rejection radio, means the op-amp ability to suppress noise and variation from the power supply. Higher PSRR value indicates better rejection of the power supply. Another parameter is input noise voltage. In this case, the parameter specifies the equivalent noise voltage at the input of the op-amp. It is typically given in nanovolts per root hertz, NV upon per root hertz, and varies with the frequency. Another parameter is the noise input current. This parameter specifies the equivalent noise current at the input of the op-amp amplifier, also given in a pico amp per root square hertz. Pico amp and per root square. So noise specification of the op-amp can be found in its datasheet and are typically given as a input noise voltage density. This is usually specified as a frequency commonly 1 kilohertz. For the 741 op-amp, the input noise voltage density is approximately 20 NV upon root hertz at 1 kilohertz. Another is input noise current density. Another is a broadband noise. This is another is a flicker noise, 1 upon F noise. So these are the few noise specification of the op-amp. In the practical implication, low noise application. In the low noise application, while the 741 op-amp has decent noise performance, it is not the best choice for the very low noise application. For such application, low noise op-amp is specifically designed for the minimal noise outperformance. Another is general purpose application. The noise performance of the 741 op-amp is generally acceptable for the many general purpose applications, including signal amplification, filtering, and the analog composition, where ultra low noise is not crucial parameters. So, in brief, you may say that the 741 op-amp handles noise through its inherent design characteristics, including CMRR and PSRR, and its noise specifications such as the input noise voltage and the current densities. While it may be not be the optimal choice for very low noise application, it serves well in many general purpose sceneries where moderate noise performance is sufficient.
Okay, thank you for the session, and I hope the people will able to learn a lot today, and they will able to get some more insights on this IC. And if you have any more doubt or if you have any more question, we are waiting for a few more seconds, so you can write it out to us, so that we can answer you out. And uh, if you have any more question, please send us urgently. So as we can see, there is no more question from the audience side. So you can always post your question on the LinkedIn or YouTube wherever you are watching, and you can also subscribe our channel, and you can also uh, uh, press the bell icon for the notification of our next session. And okay, thank you everyone. Thank you for the session today, and we will meet next Friday with a new topic, with a more interesting topic. And so thank you for now.
Thank you, everyone.